Hey everyone, welcome back to another video by Camroom 5. In today's video, we're going to be doing some mole and stoichiometry questions that's going to be useful for our A-level and O-level students both. So let's begin this question. It says carbon disulfide vapor burns in oxygen according to the following equation. A sample of 10 centimeter cube of carbon disulfide was burned in 50 centimeter cube oxygen. So carbon disulfide is 10 centimeter cube and oxygen is 50 centimeter cube. After measuring the volume of gas remaining, the product was treated with an excess of aqueous sodium hydroxide. Now, why the hell sodium hydroxide is here? Sodium hydroxide is an alkali, and that is a compound that absorbs carbon dioxide, or you can say other acidic gases. Because sodium hydroxide is an alkali and it reacts with all the acidic compounds. We will use this concept really soon. Let's see. And the volume of gas measured again, all the temperatures were made, all the measurements were made at the same temperature and pressure under such conditions that carbon disulfide was gaseous. So carbon disulfide is gaseous and we have to think about what are the measured volume of gases. Let's begin. You can see if 1 mole carbon disulfide reacts with 3 mole oxygen, it means 10 centimeter cube should very reasonably react with 30 centimeter cube oxygen. So 30 centimeter cube oxygen reacts. How much oxygen was there? Oxygen was there as 50 centimeter cube. If the amount react is equals to 30 centimeter cube, it means the amount left unreacted is going to be 20 centimeter cube. So 20 centimeter cube oxygen is there. Apart from that, you can also see 1 carbon disulfide makes 1 carbon dioxide. So you can get 10 centimeter cube carbon dioxide. So this is also a gas remaining in the product. And you can see 1 carbon disulfide makes double sulfur dioxide. So you will get 20 centimeter cube sulfur dioxide. So you can also see 20 centimeter cube of sulfur dioxide. How much total gases are you receiving? You're receiving 20 plus 10 plus 20, which is 50 centimeter cube gases. Once you receive this 50 centimeter cube of gases, you should know that after treatment with sodium hydroxide, acidic gases are gone. So this carbon dioxide and this sulfur dioxide, they are gone because they are absorbed by the sodium hydroxide. So in the beginning you receive 50 centimeter cube, but after treatment with sodium hydroxide, all the product gases are gone because they are acidic. So you only receive 20 centimeter cube after treatment because oxygen is not acidic. It won't be absorbed by sodium hydroxide. So C for Cato is the answer. Let's do some more questions. For example, this question makes sense. It says, in leaded petrol, there is an additive compound of lead, carbon and hydrogen only. This compound contains 29.7% carbon and 6.19% hydrogen by mass. What is the value of X in the empirical formula? So you have to think about, in this empirical formula, what's the value of X? You might go for the longer method of finding empirical formula. You might say, okay, let's find the percentage of lead and let's solve it entirely. Don't do that. It's gonna be a very simple trick. See, in your question, C is 8, right? So if 8 units of an atom is received by 29.7% by mass, so 8 is basically for carbon, right? So if 12 times 8 makes 29.7% by mass, then hydrogen, which is 1 times X, is making 6.19% by mass. You can simply take a ratio of that. So you can say, according to my formula, C8, which means how much mass? It means 96 units of mass is equal to 29.7%. How much mass would be made by 6.19%? So you can find that out. So what we'll do is, we're simply gonna cross multiply. And when we cross multiply, we're like 96 times 6.19 divided by 29.7. So that is gonna be 20. So X is equals to 20. Now 1 times 20. So X is equals to 20 because hydrogen has a mass of 1. So 20 is the right answer. Another method that you can go for is finding the percentage of lead than finding the entire empirical formula, but that's a longer method. I'm not saying it's wrong, I'm saying it's extra longer method. Let's do. I want to try this question also. Although it's from redox, but let's try it out, right? Ammonium nitrate can decompose explosively when heated. What are the changes in the oxidation numbers of the two nitrogen atoms in ammonium nitrate when this reaction proceeds? So I'm going to zoom in a little extra bit. You can see that in N2O, the oxygen atom is always -2. So nitrogen atoms which are 2 in number, they should be +1 each because there are 2 nitrogens. So here nitrogen is equals to +1. Now we have to figure out ammonium and nitrate individually. So first let's talk about ammonium ion. In ammonium ion, there is 1 nitrogen and 4 hydrogens, so +4, and the total number is +1 because the charge of ammonium is +1. When you solve it, you get to know that nitrogen is equals to 1 minus 4, and that means nitrogen is equals to 3 here. Sorry, nitrogen is equals to -3 here. So here nitrogen is -3. When we talk about nitrate, we are like, okay, nitrate means NO3 with a charge of -1 is equals to 1 nitrogen, and there are 3 oxygens, right? Each oxygen is -2. So that means -6 because of 3 oxygens. The total charge of the nitrate ion is -1. So I put -1 as a resultant. When we solve it further, we are like, okay, nitrogen is equals to -1 plus 6 and nitrogen is equals to +5. So here in nitrate, the nitrogen is +5 and in ammonium, it was -3. So there's a change of -3 to +1, which is a change of 4 units. And there's another change of +5 to +1, which is a change of -4 units. So +4 minus 4 should be the right answer. Let's do more questions. Okie dokes. I think another oxidation number question is not something we should be doing, but let's try this one. Sulfur dioxide is added to wines to prevent oxidation of ethanol by air. To determine the amount of sulfur dioxide, a sample of wine is treated with iodine. In this reaction, 1 mole SO2 is oxidized by 1 mole of I2. What is the change in oxidation number of sulfur in this reaction? Now it's very important. The mole ratio of iodine and the mole ratio of sulfur dioxide is 1:1. We always know that iodine changes from I2 towards iodide ions. It means the change in oxidation number for iodine is 0 to -1. So iodine gains an electron, but there are 2 atoms. It means 2 atoms are gaining 2 electrons. So 2 electrons gained. Sulfur would be losing 2 electrons because if 1 atom is gaining or 1 species is gaining electron, the other should be losing. And since mole ratio is 1:1, it means sulfur dioxide is losing 2 electrons, so 2 electron lost. Now if SO2 is losing 2 electrons, it means it's oxidized, which makes sense. So sulfur in sulfur dioxide has an oxidation number of +4 and it is 2 electron loss. So it is going to an oxidation state of obviously +6. So it's going to be +4 to +6 because iodine is gaining 2 electrons because each atom gains 1. So sulfur should be losing 2 electrons to compensate. Let's try this question. In flooded soils like those used in rice cultivation, the oxygen content is low. In such soils, anaerobic bacteria cause the oxygen blah 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 blah. Faltu information. Let's move on. In which step is the change in oxidation number of nitrogen different to the changes in other steps? Now that is a question that we have to deconstruct on each step. In nitrate, we just figured out that nitrogen is +5. So nitrate involves nitrogen at +5 oxidation state, that is fixed. Let's talk about NO2. In NO2 you can see there are 2 oxygens, so it means an oxidation number of -4. We don't know about nitrogen, but we know that the overall charge is -1. So when we solve for x, it's going to be -1 plus 4, x is going to be +3. So nitrogen here is +3. Let's move on. So it's moving from +5 to +3. In nitrogen oxide, it is oxygen is -2, nitrogen is +2. So nitrogen here is +2. It is changing then from +3 to +2. In N2O, oxygen is -2. Each nitrogen has to be +1. So that overall it becomes equal to -2. So nitrogen here is +1. So it's changing from +2 to +1. And then in pure nitrogen, it's an element. So elements are always 0 oxidation state. So it is going for 0. Now you can see that the change in oxidation number is 2 units, then 1 unit, then 1 unit, then 1 unit. So A for apple is the right answer, because in option A, your oxidation number is changing very differently than all other steps. Let's go for some other question. Let's see. Yeah, this question makes sense. The nitrates of beryllium, calcium, magnesium, strontium all decompose in the same way. When heated, when 2 gram of one of these anhydrous nitrate is heated, 1.32 gram of gas is produced. What is the nitrate? Now that is a very tricky question. You should know that when group 2 nitrates, because these are all group 2, right? So when group 2 nitrates decompose, the equation looks something like this. They decompose on heating. You receive a metal oxide. Metal could be anything. Then you receive 2 moles of nitrogen dioxide and you receive half mole oxygen gas. So how much gas are you getting? You're getting 2.5 mole gas. In my question, it's very clearly given that I'm getting 1.32 gram of gas. But which gas is it, oxygen or nitrogen dioxide? I don't know this, right? So my recommendation, my suggestion would be to notice that when 2 gram of this is heated, you receive overall 1.32 gram of this. The molecular mass, now you might be like, how do we find the molecular mass of this? Notice one thing. When you find the molecular mass, you do the mass over MR, right? What's the mass? 1.32. But you might be like, sir, which MR do we use? We use the nitrogen dioxide or do we use oxygen? My suggestion is use both with their entire mole ratio. So here, a very tricky thing is going to happen, right? What we are doing, we are using the MR for 2 moles NO2 and 1 mole O2, and half mole O2. So the nitrogen dioxide's molar mass is 14 plus 2 oxygen, which is 32, so that's 46. I'll double it. And oxygen's molar mass is 32, I'll half it. My MR, based on this calculation, my imaginary MR, I should say, becomes 46 times 2 plus 16 half, so that's 108. In this way, I am considering this entire thing as one entity. So even my mole ratio is applied here. So 1.32 divided by 108. That means 0.0122 mole gases. This entire thing is considered as 1. And this has a 1:1 mole ratio with my metal nitrate. So mole of metal nitrate is also 0.0122. Now, what was the MR? MR is equals to mass over mole. MR is equals to 0.0122 and the mass was 2 grams. So divide by 0.0122. It's 163.93. Which metal is this? Now you should know that nitrate means 1 nitrogen and 3 oxygens, right? So that is a mass of 14 plus 48 times 2, because there are 2 nitrates. So 163.93 minus 124. 163.93 minus 124. So that gives 39.9. So MR is equals to 39.9, which is 40. So it's obviously calcium nitrate. I would again recommend you guys seeing this part of the video again, so that you guys have a stronger grip on what just happened. For more questions, we'll come back again. Stay tuned, guys. Thanks. Love you.